Welcome to this explainer. Okay, let's just jump right into this because today we're unpacking a really, truly fascinating story from the absolute bleeding edge of software development. We're looking at how Gary Tan managed to ship hundreds of thousands of lines of complex code in mere months. And the crazy part? He did it after a 13-year hiatus from programming. Now, if you weren't familiar with Gary Tan, he's the CEO of Y Combinator, which is honestly probably the most powerful and influential startup accelerator in the world. I mean, they've backed giants like Airbnb, Stripe, Reddit. So when the head of Y Combinator speaks out about a massive, fundamental shift in how engineering is done, well, the entire tech industry sits up and pays attention. Today, we're going to explore the framework, the underlying philosophy, and the literal math behind how personal AI is completely rewiring what a single human being can build. Gary Tan actually perfectly captures the reality of this new era with a really great metaphor. He says, using Claude these days is like driving a Ferrari. Exhilarating, but you better be a mechanic. And we're going to dive deep into this paradigm shift in software development. Because yes, it feels incredibly fast and, frankly, superhuman. But as you'll see as we unpack this today, it requires a completely new, highly hands-on mindset to actually harness. Like, if you want to drive this Ferrari, you can't just put it on cruise control. No way. You have to be willing to pop the hood, get your hands dirty, grab a wrench, and debug the weird hallucinations when the thing inevitably breaks down on the side of the road. And really, the core of this entire shift comes down to one absolutely staggering number: 400x. The central claim of this whole framework is that by properly leveraging modern AI agents, a single person can output 400 times the amount of work of a traditional engineer. Now, look, if you spent any time at all writing software or managing dev teams, your BS detector is probably flashing red right now. A single developer outpacing an entire team by a factor of 400? That sounds like pure engagement farming internet trolling, right? Just an impossible exaggeration. But stick with me here, because we are going to look at the literal, verified metrics to back this up. All right, moving into Section 1, the proof. Let's look at this 13-year hiatus to massive output. So let's look at the mathematical reality of two actual projects built by the exact same person spaced 16 years apart. Back in 2008, Tan built a highly successful startup called Postgres. That project took a full team of about 7 people, a $4 million budget, and a year and a half to fully build out. Now, fast forward and look at the leap in 2024. His new project, which is an investigative journalism platform called Gary's List, took just 1 person, 5 days, and roughly $200 in Claude API credits. And by the way, an API credit is essentially just paying a few fractions of a cent every time you ask the AI to think, search, or execute a task. The democratization of this is just wild. A barrier to entry that used to cost millions of dollars and years of complex coordination has literally collapsed into a single week's work and a couple $100. Now, the catalyst for Gary's List was actually a burning personal motivation. Tan was deeply frustrated over California public school policies, specifically the fact that many public middle schoolers in San Francisco simply couldn't take algebra. His goal was to quickly build a neutral platform for deep research and community action around these types of hyper-local issues. But the result wasn't just, a basic blog. He built a full-blown agentic AI system. And if you're wondering what that means, instead of just answering a prompt like a normal chatbot, an agent acts autonomously. It makes decisions, it searches the web, pulls down documents, cross-references dozens of sources, and compiles data completely on its own. It acts a lot like a highly skilled, totally neutral human investigative journalist that's just tirelessly working in the background. Which brings us to Section 2, the core philosophy, or what we are calling tokenmaxxing. So how did he actually achieve this impossible efficiency? It's through a really aggressive core operational philosophy known as tokenmaxxing. To do this, you spend your API tokens aggressively to exhaustively research, test, and generate complete solutions. Historically, developers are trained to be incredibly frugal with computing power. You try to save every single penny by writing highly efficient, lean code and minimizing your server requests. Well, tokenmaxxing flips that entirely on its head. Instead of trying to economize, you deliberately pay for maximum tokens to simulate exhaustive human research. You literally tell the AI to boil the ocean, tell it to pull 20 distinct sources instead of just one, force it to cross-reference all of them, and compile massive amounts of context to make the absolute best possible decision before it ever writes a single line of code. I like to think of this aggressive token spend kind of like paying San Francisco rent. Yes, it seems ridiculously expensive to pay thousands of dollars a month for a tiny little apartment in a tech hub, but being in that hub creates serendipity, networking, and utility that makes it far more expensive to actually avoid paying it if you're trying to build a major company. Tokenmaxxing operates on that exact same logic. If you want the absolute best results, you just have to be willing to pay the machine to do the exhaustive heavy lifting. Paying for that maximum utility upfront is really the only way to operate at the cutting edge of what these modern large language models can actually accomplish today. Let's pop the hood on this. Section 3, Under the Hood, Building with GStack. Tan manages this massive, crazy workload through a custom automated toolkit he calls GStack, and it relies on a very specific loop. Step 1, he actually forces the AI to generate ASCII architecture diagrams and state machines before it even starts. ASCII diagrams are basically just simple text-based visual maps, and state machines are the logical steps and transitions a user takes as they move through an app. He forces the AI to map all of this out first. Then, step 2, Claude runs as the visionary CEO or designer to map out the ideal user experience. Step 3, he pushes that exact vision to a secondary agent, Codex, which acts as a hyperlogical developer hunting for bugs and fatal flaws. And finally, step 4, mandatory human quality assurance and review. So it's quite literally a sequential assembly line of distinct AI personas checking each other's work. Now, the real secret sauce as to why this loop actually works is prioritizing prompting over programming. The key is relying on Markdown rather than jumping straight into writing code. Markdown is essentially formatted plain English, and it lives in the AI's latent space. That's basically the AI's underlying brain, or this vast web of connected knowledge where it naturally understands nuance, human motivations, and weird edge cases. On the flip side, traditional code is just deterministic zeros and ones. Code is incredibly brittle. It fails completely on edge cases because it doesn't actually understand what you want. It only knows exactly what you typed. So the magic of modern engineering is keeping all your complex logic and decision-making in plain English Markdown and only using code for the rigid, deterministic execution at the very end of the line. But wait, there is a massive catch to working this way. If you just let an AI write code based on pure vibes and plain English prompts, you get what developers affectionately call slop. This is code that works perfectly for the 80% happy path, when everything goes exactly right, but it completely falls over the second a real, unpredictable user touches it. And if that happy path breaks down, your entire app breaks down, and users bounce. To make this system actually work, you must force the AI to generate 80 to 90% test coverage. You literally force it to write code that constantly tests its own code. Without those strict guardrails and mandatory human QA, the software simply won't remain stable in the real world. All right, moving on to Section 4, Data and Nuance, the Lines of Code Reality. So when Tan first claimed he was operating at a 400x multiplier, critics immediately attacked the metric. They argued, hey, AI simply pads code unnecessarily just to inflate the numbers. And look, historically, traditional human developers output roughly 14 to 50 production-ready, fully tested lines of code a day. But Tan's AI agent loop was shipping hundreds of thousands of lines a month. To prove the skeptics wrong and ground this metric in actual reality, Tan ran well-published, industry-standard scripts that strip away all the bloated code. We're talking scripts that remove comments, empty spaces, and repetitive, useless functions to measure absolutely nothing but the pure, logical code. And the verified metric? Even after rigorously stripping out all the bloat, compared to his human output back in 2013, the 400x efficiency multiplier remained completely mathematically sound. Let's do a quick reality check here. Section 5, the reality check, the irreducible human element. This brings us right back to the Ferrari. The AI Ferrari will break down. Despite these superhuman productivity metrics we just talked about, AI is not a magical, frictionless cure-all that just builds profitable companies while you sleep. Most importantly, it cannot replace human desire. You still absolutely need a human who cares deeply about an issue, like local middle school algebra policies, to kick off the entire process. The AI is inevitably going to get stuck in a logic loop, or brick itself, or generate some massive head-scratching bug. And this means human agency, human taste, and the sheer willingness to act as the mechanic remain the irreducible core of this entire workflow. The machine is doing the typing, yes, but you absolutely must do the driving. Which leads us to Section 6, the paradigm shift, becoming the time billionaire. All of this leads to just a totally fascinating realization. Tan says you could have infinite time by borrowing the time from the machines. In the age of personal AI, you kind of have to stop thinking of yourself as just an employee or a builder. Think about it. In a normal 9-to-5 job, your output is strictly bound by the 24 hours in a day and the physical limits of your own energy. But by token maxing and directing these autonomous agentic loops, you are essentially borrowing millions of years of compiled machine consciousness to do your heavy lifting for you. You can effectively become a time billionaire, living out entire lifetimes of productive output and building massive, complex systems in a matter of mere days. And that leaves us with a final, really profound question. Will you have control over your tools, or will your tools control you? The defining challenge of this new era isn't whether the AI can do the work. I mean, we mathematically know it can at this point. The true question is whether you have the vision, the specific taste, and the unrelentless drive to roll up your sleeves and actually direct it. So what are you going to build with your borrowed time? Thanks for joining me on this explainer, and I really hope this sparked some serious curiosity for whatever project you decide to tackle next. Catch you next time.